Right now, we start today talking about the distinction between hard methods and soft methods in operational research. Now, we know that we have seen the methodology of hard OR, and we have also seen a case study. And I ask you to conduct also a term project on hard OR, so that's all about hard OR we have. Now, in this lecture, we look at an example where soft approaches are needed, and we talk about the characteristics of soft systems problems. Terminology, a list of some methodologies in soft systems, and we shall proceed later on in more detail in the coming lectures. Now, the hard and soft distinction, the division between hard and soft systems or systems thinking is not very clear, and it's not exact. Soft aspects are almost always present in all problem situations. Even though a problem situation is suitable for a hard OR approach, this does not mean that soft aspects are totally absent in that situation. And vice versa, when we have pluralistic or coercive situations, which we know that are the subject of soft approaches, in such problem situations, sometimes it is possible to construct mathematical models of hard OR and vice versa. So one can be embedded in the other all the time. The soft perspective should not be neglected altogether when doing hard OR and vice versa. So, and most importantly, problem situations that look suitable for hard OR at first sight are often more complex than we realize, okay? Now, when you take up system design projects next year, I can say that several of those, I mean the majority of those projects that our students work on are suitable for a hard approach. In the past, it was about 50-50. Half of the projects were suitable for soft approaches, half for hard approaches. Now it is more hard of the hard type, but nevertheless, in all those cases, it will be very suitable for you to start addressing the issue as if it's a complex and soft issue, okay? The time will come within that project to make use of mathematical models and hard thinking. At first sight, the problem might look to you to be suitable for a hard approach, but it is never like that, okay? Now, I have constructed this example some years ago. I have used Michael Pidd's book and translated into Turkey and constructed this example about the Bakü-Ceyhan. This is the Bakü-Ceyhan example. It goes like this. As you know, oil is being pumped through the pipelines from Azerbaijan in Bakü to Ceyhan. And in Ceyhan, BOTAŞ has depots where the oil is stored. And then ships from all over the world come arrive at the Ceyhan port, and the oil is pumped from the depots into the ships, into the tanker ships, and then they are taken away to world markets. Now, when oil is being pumped from the land to the tankers waiting in the sea, some hoses are used, hortumlar. These hoses are very, very large, about 1 meter in diameter. They float in the water, okay? They are subject to forces of the waves, etc. And then oil is pumped through these pipes. These are flexible hoses. And when something happens, I mean, if there is a storm or something, these hoses can fail. They are ruptured, perhaps, or broken. And when that happens, of course, there are large oil spillages into the water, which causes a lot of environmental damage. Of course, when this happens, the pumps are switched to auxiliary hoses, but during that time, spillages can occur. Until recently, the hoses have been bought from a company we shall call ABC. This is the supplier who was the original manufacturer of these hoses. These hoses obviously are high technology products. Over the last 2 years, let us assume that 2 new suppliers have appeared on the market. We shall call these TUV-XYZ. And they are saying that if you buy the hoses from now on from us, there will be a price advantage for you up to 40%. So they are undercutting the ABC prices by up to 40%. They are cheaper, these new hoses. And the port manager, the Botaş, let's say, port manager, we shall call him PM, is of course interested in this new offer because he would like to cut his costs. And he has insisted that one of the pumping stations should be switched to the XYZ hose for a trial period. He says, let's try this new hose. If it is reliable enough, then of course we shall be making a lot of savings, and it's very important for us. And during the trial, there have been some problems. And the Botaş pumping officer, so there's another person now, we shall call him PO, the pumping officer. This is the engineer who is responsible for the pumping operation, is unhappy about what he feels is a much higher rate of hose failure than was the case with the ABC hose. He says that these XYZ hoses are perhaps cheaper, but they are subject to more frequent failures. And he's not obviously happy about that because his responsibility is the safe pumping of oil to the waiting tankers. And if hoses fail, of course, his duty will not be done. His job will not be done. The port manager, the pumping officer, the Botaş maintenance manager, MM, is another engineer who's responsible for the maintenance of these hoses. And let us assume you, the industrial engineer, a Botaş industrial engineer, discuss the situation, and the conversation goes something like this. This conversation I have copied from, I have transferred from Pitt's book, okay? The port manager says, yes, I know that the hoses seem to fail more often, but look at the price. We save 40% on the prices charged by ABC. I'm not bothered about shorter service lives with that reduction. If the failures are more frequent, the expected time to failure, is shorter, obviously. But he says that I'm not troubled with this because the prices are very nice. The pumping officer says, even if the life is only 50% of ABC hose, will you be able to accept this? He says, the mean time to failure is about 50% of the original hoses. And PM says, come on, it's much higher than that. The maintenance manager says, well, I'm not too sure about that, but I don't really know. He's not very sure about the time to failure being 50% less. But he says, I don't really know what the failure rates are. I'm sure that we could improve things by better maintenance. So he says that even if we switch to these new hoses, which are less reliable, apparently, by proper maintenance, we can get around this difficulty. This is the claim of the maintenance manager. Port manager says, but if we stop the pumping just for preventive maintenance, then it costs money. You know that maintenance is of 2 types. You can, when a piece of equipment or machinery fails, you can repair it. But in order to prevent failures, you can also conduct preventive maintenance, koruyucu bakım. This means that you have to take the piece of equipment out of operation, do the maintenance, and send it back into operation. Normally, of course, preventive maintenance is very important in systems. This is an important area in industrial engineering, reliability and maintenance. It's a subject in stochastic processes. There have been many models constructed for such situations in operational research. Preventive maintenance, the MM says we can do a lot of things by preventive maintenance to lengthen the time to failure, but the PM is worried about having to take the pumps out of service, during which time, of course, service will be lost, and there will be penalty pay to the tanker owners for a start. I mean, this is called a penalty payment has to be paid by BOTAŞ if the tankers have been kept there unnecessarily waiting more than they should wait. The maintenance manager says it's still cheaper than having a hose blow oil all over the harbor when it fails. It is still cheaper, that is, conducting preventive maintenance is cheaper than doing the repair work, because if we have to do repair work, there will also be spillage and costs coming from contamination of the water. Then we still have to stop pumping, but we also have to replace the hose section. Then we have to clean up the harbor. We also have the greens on our backs about pollution. I'm sure the better maintenance is the answer, he says. NPM says, but it all costs money. There must be some way to work out what to do. Don't you have any ideas in the IE department? So this is the situation. It looks like not a very complicated situation, perhaps. Let's see the elements, the components of this problem situation. It appears to be suitable for a hardware approach because it's all about costs. It's about making choices between 2 types or 3 types of hose by 3 manufacturers. You have to compute the costs of this and select the hose which promises the minimum cost. So it is quite suitable for hardware at first sight. The controllable variables, these are the decision variables, seem to be the type of hose selected, ABC, XYZ, or TUV. And then there is a second decision. The maintenance policies applied to the hoses once they are in use, because you have to apply some sort of preventive maintenance or some sort of maintenance policy. So there are these 2 decisions to be made. There are some uncontrollable variables, like the expected life of the different types of hose. This may be expressed in terms of a probability distribution. The time to failure is a random variable. You understand when I say time to failure? It is the duration of time from now until a failure occurs when the piece of equipment is in use, when it is being used. Okay? It's an important random variable in stochastic processes. It's written TTF, time to failure. MTTF is the mean time to failure. You can see these expressions in OR text, but probably you did not study reliability in OR. It's a little bit more advanced subject in stochastic processes. So this is a random variable, and the information about the hose being subject to such random failures is provided by the distribution function of the random variable. If this probability distribution or distribution function is available, then you can compute the probability of failure at any time in the future, etc. You can compute the means, modes, medians, and all sorts of measures having the probability distribution. Other uncontrollable variables are the purchase prices of the hoses. The price, it's said that it's 40% less than the original hose price, but again, these are not exactly known, perhaps. So it is the likely purchase price, the expected purchase price, because expensive items like such technological hoses, etc., do not come under standard prices like when you are buying Coca-Cola. The price is subject to a lot of negotiations, and it's not clear at all at the beginning. The likely costs of spillages, the oil spillages, should they occur, this may also be expressed in terms of a probability distribution, which we don't know how much of a cost we shall incur if an oil spillage occurs. The costs of different maintenance policies, so these are the uncontrollable variables. Uncontrollable variables in other terms are the data that you need. The decision criterion seems to be straightforward. It's to minimize the expected total cost, where the expected total cost is the sum of three types of expected costs: expected purchase cost, expected maintenance cost, and expected spillage costs. These are all expected for the reasons we have explained. So what sort of data do we need? We need the hose prices. There may be no price list for such expensive items. Instead, the prices may be negotiable. These are always negotiable, pazarlığa tabi, between BOTAŞ and the supplier. So we have to work with expected prices rather than exact prices. Expected maintenance cost, first, are there any proper records of the cost of existing maintenance policies? This is the first thing we have to question. There must be some existing maintenance policy. So have we recorded the costs of this policy? Now, in my experience in industrial organizations in Turkey, we often have student projects, system design projects associated with these problems, maintenance problems, replacement problems. And our students would like to obtain such costs, and they go and ask the managers there if they have collected data. The managers say, oh, we have all the data. And then when we look at the data, we can see that it's completely useless, and they haven't really collected any data. So this is a problem in your profession always. The data associated with existing policies is usually not recorded. Even if they are available, they may be used to estimate the likely cost of applying similar policies. We can use them as a proxy to compute the cost of our new policies that we may propose. The complications then begin. Is it reasonable to assume that similar policies will be needed for any type of hose? We don't know that. Probably not if we take seriously the views of the maintenance manager. He says, I am sure that we could improve things by better maintenance. So he has in mind different policies than used before. This means that the apparently simple decision model based on cost minimization may depend on at least one other model that attempts to show the costs of different maintenance policies. To compute the costs of different maintenance policies, the expected maintenance cost would probably require a stochastic model, which is not straightforward at all. The third component is the expected spillage cost. This will have at least two components. First, some estimate of the likely cost of a spillage. You would like to know the expected cost of a spillage, and also, of course, we would like to know the number of spillages that are likely to occur. We have to know the frequency of spillages. Sometimes in reliability theory, you have to also compute the duration, frequency and duration of failures. These are the two important random variables in reliability theory, the frequency of failures and the duration of each failure. Both the frequency and the duration will incur different types of costs normally. So you can see that there are complications. There's some model showing the link between maintenance and hose life will have to be constructed. Thus, an apparently simple situation involving a choice among only three types of hoses can turn out to be more complicated than it appears at the first sight. This is much more than a simple minimization problem, since lifetime distributions are hard to estimate, and also the effects of maintenance policies are not easy to estimate. Suitable data will probably not be available. And even if reliable data will not be available, it will not be possible to compute the cost minimizing solution. These difficulties will complicate the problem situation even more. What do we mean by even more? This is important. There will probably be a divergence from unitary purpose. The unitary purpose at the beginning was to minimize the total costs. This purpose or this objective was shared by the three people, the MM, the PO, the PM, probably. But as it turns out that exact valuation of each of these costs will be difficult to estimate and pinpoint, then this will start a process of divergence of opinions. Of course, because the different stakeholders will have different purposes. Now, the PM, for example, was identified as the problem owner. He is the manager of the whole facility. But there are other stakeholders like the pumping officer. The pumping officer, for him, continuous and safe flow of oil may be more important than cost, because his duty is to see that oil is pumped in time and safely to the tankers. For the maintenance manager, an opportunity to show how effective maintenance is could be the most important concern, because he says that by proper maintenance policies, the expected life of the new hoses can be lengthened, can be more acceptable, and he would like to show that he can do this. So his concern is probably more about his policies than on cost minimization. Therefore, if these two internal stakeholders are not consulted and decisions are not taken jointly, any solution proposition will probably fail. And there are also external stakeholders in this situation. For example, tanker operators. The tanker operators, these are the customers of Potash. They expect fast and reliable service, irrespective of, they don't care about the costs that Potash incurs. They expect good service. Politicians, for example, this is a big operation, like an oil terminal is a big operation. It's important for the city, Ceyhan. It's important for the government also. So they can have their own views about hose suppliers, hose failures, and service quality. These hoses are expensive, and the suppliers can come into contact with the mayor, the belediye reisi, the other politicians, etc., and they might have different ideas. There are environmentalist groups will put all emphasis on reliability of pumping, like the Greens, the Greenpeace, and other groups like these. Local residents also applies, etc. There are many other stakeholders. So the conclusion from this exercise is that the problem was described as a problem of hose choice, but we know little or nothing about the history of the issue. We haven't been told anything about what has happened in the past at the Potash operation. We do not know why this group, for example, led by the port manager, has decided to search for a possible new supplier of these expensive hoses. Why are they looking for a new supplier? Is it just because the new suppliers are promising low prices? It could be pressure from one of the external stakeholders. It might be dissatisfaction with the existing ABC hose. It might be that other pressures within Potash make it important that something is seen to be done at Ceyhan. So it may be internal politics who has forced the port manager to consider these new offers. Because the new offer, although it seems cheaper, is clearly not very reliable, okay? So we don't know about the history. So we have to probe and understand why they are looking at this problem situation as they seem to be in the conversation there. There are many possibilities, such possibilities, and the careful analyst, this is yourself, the industrial engineer, you cannot afford either to ignore or accept these. You have to work on all these possibilities. They all form the mess with which she has to work. This is the mess, the complicated, the complex problem situation. The problem situation appeared to be simple enough in the beginning, but as we probe it in this way, it starts to look like a mess. Problems, we have to understand, do not exist in a vacuum. They are not something that exists independently of us. They exist in people's minds and relate to their experiences of the world and to their expectations. Maybe some of the local politicians, the head of some political party in Ceyhan, for example, has been approached by the new suppliers who wants him to put pressure on the port manager to switch from the original hoses to their hoses because they will make a lot of money. Who knows? I mean, so the expectations can differ from people, from one stakeholder to the other. A purely functional hardware approach no longer appears to be sufficient in this problem situation. We have to probe this. This does not mean, of course, that we are not going to be able to use any hard model like which computes the expected costs and chooses on the minimum alternative. This is still possible. It will have to be done at some point within the project later on. But first, you have to clearly understand what's taking place here. We are going to come back to this example later on in the coming lectures when we study the soft system methodology, Checkland's SSM, and use this example to do some exercises in SSM later on. Now let's leave this example behind and go to what we mean by soft systems thinking and soft OR. By the way, soft OR and soft systems thinking, you can assume that they are the same thing. You remember I showed you a map of problem situations, and we partitioned that map and said, for example, this, if the problem situation falls in this area, we said that hard OR would be suitable. If it falls in the emancipatory area, for example. And we, in that diagram, we have hard OR, soft OR, and systems thinking as different entities. But the use of terminology in this area is not exact. It's not very easy to say, is systems thinking different from soft OR? Soft systems thinking and soft OR, are they different? So it is better to assume that they are the same. When we see the adjective soft OR, soft systems, they can all assume to be the same. Now let's look at the history of OR just a little bit. Churchman in 1960, for the first time, then Aikoff, Checkland and others, rather than accepting the narrow rationality of economic thought, they recognize that human decision-making is more complex and varied, and is also bound by concerns which are other than economic values. They discovered that the process of decision-making affects whether or not a solution is accepted. Okay, normally hard OR assumes that we can make our decisions on economic grounds, like minimizing costs, maximizing returns, maximizing profits. These are all economic concepts. But these people have seen that if you make a proposition by using a model based on economic rationality and propose a solution to the stakeholders, to the owners, this solution may not be accepted because it's not the content of the project that is important. It's the process of making the decision is more important. The process of decision-making greatly affects whether or not a solution is accepted. So they expanded this narrow quantitative optimization focus to include ideas from other disciplines, such as critical philosophy, sociology, and organizational behavior. And this mixing of boundaries between disciplines can be seen because problems do not respect discipline boundaries. A problem doesn't have to squeeze itself into the boundaries of a discipline defined by the members of that discipline. Problems are independent of disciplines, and they span boundaries. They flow over the boundaries of disciplines. And narrow economic focus is not sufficient. And that human efforts for quality of life, happiness, aesthetics, equality, justice, etc., are also legitimate and important in human systems. The proponents of soft OR approaches point out, soft OR approaches, they point out that the majority of real-life problem situations in business, in industry and government violate most of the assumptions of hard OR. The assumptions of hard OR, we have studied these in lecture 6, as you remember. Most of these assumptions are not valid in real-life problem situations, unfortunately. Furthermore, the human aspects inherent in the problem situation and the intervention process used should not be separated. as we shall see. Soft systems approaches were designed to deal with complex problem situations. We studied complexity. Our study of complexity theory, as it is developed in physics, chemistry, and other hard sciences, was for the purpose of understanding that life is complex. Problem situations are almost always complex. Sometimes within that complexity, there will be room for rational thinking and OR models, hard OR models. It is possible. I should say frequently it is possible. But regarding these situations from the hard perspective is usually not suitable. You should always regard them from a complexity perspective. If you do not respect the complexity of human organizations, you will not be a good engineer. You have to respect life. Life is complex, and humans are complex entities. You cannot reduce the entire humanity, complex humanity, into a single dimension of money and cost and profit, okay? You will most likely fail if you do that. This is the idea of soft approaches. So the complex, which are always messy, ill-structured, ill-defined, and not independent of people. In other words, where different stakeholders with different worldviews have different and possibly conflicting perceptions about the problem situation, you need the soft approaches. Now, these ideas, of course, are not entirely new. We have mentioned such ideas before also, so this is just a repetition from a strictly soft perspective. We have talked about worldviews, and different worldviews are the Weltanschauungen. Different stakeholders, we know who they are. We have seen that objectives cannot be unitary, they may be pluralistic, and they may also conflicting depending on the perceptions, etc. So let's see the characteristics of these approaches. One other word that is often used in the literature for soft systems thinking or soft OR is PSM. If you look at the literature sometime in the future, maybe on your own, you will see this as a keyword. PSM is the problem structuring methods. So soft systems thinking can be called PSM or soft OR. The emphasis here is structuring the problem. Out of the mess, ill-defined problem situation, we try to extract a structured problem that we can address. We can possibly address using hard OR later on, or not. So these are problem structuring methods, structuring the issues in a problem situation rather than narrowly focused problem solving. So the emphasis is not on problem solving as it is in hard OR, but on problem structuring. Facilitating, the second characteristic goes as far as facilitating dialogue between the various stakeholders with the aim of achieving a degree of shared perceptions of the problem situation rather than providing a decision aid to decision makers. So in hard OR, normally we try to design a decision support structure, a decision support system as a decision aid for decision makers. Here, the idea is different. Here we try to facilitate dialogue between conflicting stakeholders. We would like them to speak to each other, but in a formal way, in a useful and efficient way, an effective way, so that they can share some perceptions which might be different in the beginning. Thirdly, we say that addressing the what question comes first, and the how question comes afterwards in soft approaches. The what questions like, what is the nature of the issue? What are appropriate objectives given the various worldviews of the stakeholders? If there are different stakeholders, what are the suitable objectives? What is the appropriate definition of the system for the issue considered? So all the what questions are important. Which changes are systemically desirable and culturally feasible? This is quite important, these are underlined. The propositions for change that you can formulate at the end of your research, I expect you to make some propositions in the term project, for example, in the transportation problem for the term project. You have to make some propositions. These propositions, whether you obtain them through hardware, software, or whatever, they have to obey these two criteria. They should be systemically desirable and culturally feasible. Systemically desirable means that your propositions should make improvements in the long-term objectives of the system, the effectiveness. They should be systemically desirable. The system should benefit from this. Furthermore, even if they are systemically desirable, it may not be possible to apply them because they can run against the culture of the system. The culture of the system may reject your solutions. This occurs very, very frequently in work organizations. New, inexperienced industrial engineers graduating from our department who are very strong on quantitative subjects because they have been good students, have been successful in all the classes they have taken, courses they have taken. When they take a job in some organization, this could be an international organization in Istanbul or in Europe or anywhere, they often start naively, I should say, and they may think of proposing a solution they have obtained, which might be obvious to them, which will surely introduce improvements into the system there, and they may have calculated this through a lot of modeling, etc. But they will find that nobody will listen to such proposals, or even if some people listen to it, they will reject it. Olmaz diyeceklerdir. Because it runs against the culture. So culturally feasible is quite important, as we shall see again later in greater detail. So how are these changes best realized? These are the questions that soft approaches have to address. Number 4, eliciting the resolution of the problem from the stakeholder themselves rather than from the analyst. Normally in hardware, the solutions to the problem are formulated, are calculated, computed by the analyst. Here, it's different. Here, as you can see, we don't talk about solution, but we talk about resolution. Now, you should know the difference between solution and resolution. I have given you a quiz on that. So it's the resolution of the problem, and this resolution should not be formulated by the industrial engineer. It should come out of the stakeholders talking to each other. The industrial engineer has the role of facilitation. Kolaylaştırıcı deniliyor Türkçe'de. Moderatör de deniliyor. Changing the role of the problem solver to one of becoming a facilitator. The problem solver is the analyst. And resource person who relies on the technical subject expertise of the stakeholders. Bu cümle yanlış olmuş. I mean, the stakeholders should rely on the technical expertise of the IE, but the IE should provide technical assistance, but work only as a facilitator, as a resource person. As a resource person, the other stakeholders can come to for advice and for help, for support. Okay, so finally, this is an important remark at the end. The how question, which comes later, note that the how questions, that is, which means are the best for achieving the desired objectives. The how question answers which means and ends, hangi araçlar, which means are the best for achieving the desired objectives. This is the subject of the how question. This must ultimately also be addressed by soft systems approaches. I mean, the soft system approach has to answer the how question also, but the answers are often almost obvious rather than being center stage as in hardware projects. The answer to the how question in hardware is at the center of the stage. This is all we try to do in hardware. In software, the answer to the how question usually turns out to be obvious once you answer the what questions. Okay, this is another characteristic. Not always. In some cases, when you deal with all the what questions using soft OR, there may be room and possibility for using a hard OR model to answer the how question. Ideally, it should be like this. That is why, I mean, I don't want you to misunderstand what I'm saying here. Our students, when we start talking about soft approaches and the importance that we should attach to problem situations as being soft in the beginning, or realizing that we should approach them as if they are complex situations that need a soft approach, etc. We emphasize this a lot of times, but you should not take this as if we are saying that I'm saying that the mathematics of hard OR is not important. I'm not saying that. The mathematics of hard OR is your most powerful weapon in your practice as professionals. If you are capable of using those techniques effectively in your work, you will be extremely successful. But the key to effective use of mathematical quantitative methods is the soft approach. That's what we are trying to, this is our message in this course. This is a diagram in our textbook, which is similar to the modeling, the formulation, modeling, and implementation phases of hard OR. In problem structuring mode, PSM, in problem structuring methods, it looks something like this. As you can see, there are more goings and comings from and to each of these three phases: formulation, modeling, and implementation. And the implementation looks a little bit different from what we had in hard OR. And also the items are a little bit different, as you can see. We start the formulation by exploring issues within the problem situation, explore the issues, identify the stakeholders, justify the boundary choices, and move around in circles from one item to the other several times. Then in modeling, we answer the what questions, select what's to be analyzed, and define the narrow systems of interest, explore different hows and corresponding system behaviors, etc., as you can see. So this is a rough. And in the implementation, choose, starting from the bottom there, choose preferred system and corresponding actions, plan implementation controls, assign responsibilities, implement actions, and monitor, etc. So this is, now, when we mention the term soft system methodology, I'm afraid that there may be a confusion here, so please pay attention to this. Soft system methodologies, there are many of these. There's not a single soft system methodology. This is a list of soft system methodologies. And we also mentioned the name of the group or the person or the professor who has first formulated this each methodology. Gaming, for example, war gaming, have you heard of this? Business games, etc. Probably you have heard of this. Sometimes our verimlilik grubu enters such competitions in gaming in the recent years, I remember. It was first formulated at the RAND Corporation. The RAND Corporation, we have mentioned, this is a famous organization belonging to the American Air Force, military. But it's a very powerful research corporation in California. They publish a lot of papers in economics and technology, etc. So gaming. Metagame analysis, again, and this is from the Army. Strategic choice approach by John Friend. Strategic assumption surfacing and testing by Mason and Mitroff. Social systems design by Churchman. Social system sciences, or sometimes it's called interactive planning by Aikoff. So there are many soft approaches, as you can see. There's another one, SSM. The confusion comes from this. SSM is soft system methodology. But I'm saying that there are many soft systems methodologies. One of the soft systems methodologies is called soft system methodology, unfortunately. And we call it SSM in order for you not to confuse it with the general, okay? Checkland actually is the first person who used the term soft system methodology, and his methodology is therefore known as the soft system methodology, but there are many others, okay? So there's this confusion. Don't let this confuse you. Others like SODA, strategic option development and analysis. This is known usually as SODA. Hypergame analysis, robustness analysis, theory of constraints, critical system heuristics, drama theory, very interesting, drama theory, is used in software, drama theory, total systems intervention, multi-methodology, etc. So we are not going to study all of these, obviously, and our textbook actually tries to summarize some of these, but it does a bad job of doing this. The chapter on soft system methodology in the textbook is not good at all. Dallenbach tries to explain SSM. This is the most famous. SSM is probably the most famous and most widely applied soft methodology. So he talks about SSM. He also talks about, I think, SODA and strategic assumption surfacing and some others, but in very short paragraphs, which is not useful at all. So I'm not going to spend any time on those. I'm not going to use the textbook on SSM at all. Our lectures on SSM, which are the coming 2 lectures, are completely independent of the textbook. I have uploaded at the website the Checkland's chapters that address those PowerPoint files, but I have not made them required reading, and but to read the details, the readings are assigned, are posted at the website. There are 2 of them. One is called SSM, a skeleton account, and the second one is SSM, a fleshed out account. The skeleton account is an introduction to SSM. This is a chapter in a new book by Checkland. We have uploaded it on the website. And a fleshed out account is a detailed explanation of SSM. Again, the chapter from the same book. So these 2 chapters are available for you. I would expect all of you to read it at least once to understand the PowerPoint files properly so that you won't have difficulties in the exams.